we have just discussed about Android, some keywords and different Android installation steps. So I told like we have to make ready with the Java development kit as well as Android Studio, everything. Okay. So after that, today we will work out this Android architecture. So it is very, very important before going learning about our Android stuff. So Android architecture. So it's a predefined thing from Android SDK. Like before Android SDK, what is their plan and how they implement it? Okay, so that related stuff we are going to be discussing this. Last class we have done this. So we are learning about Android architecture today. So this architecture, in the sense, basically, what do you mean by architecture? We'll just define. So consider architecture is nothing but before proceeding any development. So what is the way of your execution? So I can say like this is a plan before implementation. Before implementing a project or something or product, consider product, because Android is a product, right? So before implementing the product, there is a way. What is the way and how we are going to be work out and how others can access, because their intention is they want to implement open source mobile operating system. That is their intention. For that, they have drawn this architecture. Still, this architecture only we are following. But even though they have given for open source mobile operating system, but now it is working for rest all other things. Okay. Let's see what is this architecture contains. Okay, how they divide it. So this architecture contains total 5 layers. 5 layers. In interview, nobody will ask what is what like that. Just they will ask what is an architecture, what are the component, what are the layers available in that, and what is the main intention of that architecture. Like that they will ask. So we'll discuss same. Right. So Android architecture contains total 5 layers. So whatever the diagram I have shown, that is the architecture diagram. So what are the 5 layers? We'll go one by one. First one is Linux kernel layer. Linux kernel layer. So there is one more name for this. This is called hardware abstraction layer. Hardware abstraction. So in the name itself, you are able to see hardware abstraction. So hardware abstraction means this layer specifically designed any third-party layers, third-party hardwares, or in your phone, different hardware devices are available, right? Your phone is combination of two things. One is hardware and software. Software they are doing, but how about hardware communication? That the communication, it was imposed in the Linux kernel layer. So what is this Linux kernel layer contains? Okay, simple step. Linux kernel layer, it contains device drivers. Your mobile device, what are all it contains? Different features. Like for example, in my device, I have a camera. So I want to use that camera. So how to use the camera? And when you in the software, you will have a camera app. So when you click on the camera app, automatically it will launch the camera. So camera will give you a mirror image of your capturing thing, right? So camera, it is built with some lenses, which is kind of hardware, right? So that hardware you are able to get activated by using a software program. You are just launching it by using a software program, and you are able to capture it, and you are able to get the camera result into your code. All these things we have in the Linux kernel. Not only camera, you have Wi-Fi, you have vibration, you have battery. What are all the hardware things will be available? Chips, data processing, everything it will be taken care. So in this Linux kernel layer, all the things will be filled with device drivers. So what is this device drivers? So device drivers are nothing but which was implemented by Objective-C or C programs. Objective-C and C programs. So basically, I think whenever you format your Windows PC, you also need to install audio drivers, right? So without audio drivers, you can't able to operate audio and video like that. See here in the diagram, Linux kernel layer is at the bottom. So we are learning about bottom to top because there is a dependency. So here in the Linux kernel layer, you are able to see display driver, camera driver, flash memory driver, binder IPC mechanism. IPC mechanism means inter-process communication. Okay, so one application to another application communication mechanism. Power management, audio drivers, Wi-Fi driver, keypad driver. Right. Okay, so many drivers. So here just some of the names are mentioned, but so many drivers, more than 160 plus drivers are available in the Linux kernel layer. It is available there. Okay, so all these drivers are fixed. Okay, you can't delete because completely it was considered it is abstract layer. Spelling mistakes. Abstract layer. Okay, so it is completely abstract layer. Okay, cannot add or delete any driver. Okay, it is specific to only mobile vendors. Okay, only mobile vendors can do this. So can mobile vendors add or delete any driver? Yes, because Android is facilitating that option. See, some phones they are giving extra options, some phones they are not giving extra options. For example, nowadays 5G is a new concept, right? So 5G signaling need to be captured. So for that, we need a specific driver to be added. So whatever 4G supported phones are there, it won't work for 5G, I guess, right? So for that, the separate new branded phones we have to purchase because some new driver was added for to capture the 5G enabled signals. Okay, that's what nowadays in the ads we are getting 5G enabled like that. Okay, so this is what happening with the market. So mobile vendors can Android operating system allowing mobile vendors can add or delete any kind of new drivers as per their requirement because it's mobile vendors wish. Okay, right. So other than this, nothing is there in the Linux kernel. So these drivers we can't touch and we can't able to see also, but there is existence of some device drivers. Okay, so as of now I know the count is 164 something, but maybe in the new 5G or something, how many count we will get, we won't see, because it was completely abstracted information. Okay, so that is one thing. So Linux kernel main layer is main thing is just it has to interact with the hardware. Whenever my operating system would like to communicate with software commands, it need to respond for software commands. Then I will use the then Linux kernel will start doing that thing. Okay. Next, second layer we have. What is that? Is libraries layer. Libraries layer. So in the name itself, it is showing libraries. See here, you have libraries layer. Like how mobile vendors they are able to kept some drivers. Android also displaying or Android also maintaining some predefined libraries. For example, let me start Android Studio. I have already installed Android Studio and I have created some programs. Okay, so in that, how Android SDK will display libraries, I will show you. So this main intention of this libraries is we have some predefined libraries available in our Android SDK. So those are helpful to make your application implementation as per your requirement. Okay, so here some libraries they have given: Surface Manager, okay, Media Framework, Audio Video Controls, SQLite, Android Internal Database, how to create, okay, WebKit. You are downloading and launching Web Chrome, okay, Mozilla, as well as some browsers you are going to be used, right? So those browsers actions it is going to be do. libc, any C libraries you want to add for third party device hardware things. Yesterday I told like other vendor, that means mobile SIM card vendor can insert a new hardware, right? So to capture that new hardware detection and everything, this libc will work. And SSL networking, free type, OpenGLES, that is considered as OpenGLES considered as surface management, sorry, user interface related. Any high level user interface you want to add by implement by adding some libraries. Okay, SGL, some different kind of libraries are available. So these are helpful while implementing our Android application. This is I'll write here. Android software libraries. Okay. So if at all I want to tell it is, these are all called SDK component, SDK libraries. Okay. SDK libraries. Android SDK libraries. Okay. See here, I have just created some unbounded service example. Here, external libraries are there. Open this. Just a minute, still it is loading. Here, Android API 32 platform. 32 platform is the latest platform that it was there. Open this. Here you have android.jar file, root file. Open this. Here you have different folders again. All these folders contain some different libraries. For example, if I open Android, see, accessibility service, accounts, animation, annotation, app. Okay, for example, let me go to animation related some number of classes. These are all libraries only. Okay. Yeah, I want to implement the animation. I'll use this property rector, time animator, time interpolator, type evaluator, value animator. Like this, so many things will be there. So you have to use any of the one animator. Okay. Animator is a class. See, animator. It is a fully abstracted class. It contains only methods. Animator inflator. It is a normal class which contains load animator, load state and state list animator. Like this, we have some different uh, predefined libraries are available. Along with that, see, these are SDK libraries. These are SDK libraries. We have some third-party libraries also available. See here, this is Java library. Okay. So after API 32 library, we have Java library. After that, see some Gradle libraries are available. Third-party libraries. Okay. In this also some predefined classes are available. Android X activity. Okay. It contains some result cancelable. All these things. On back pressed callback, on back pressed dispatcher, on back pressed dispatcher owner. So many things will be there. Your device contains back button, right? In your mobile device, bottom of the screen, you will have home button, back button, menu button. So how to handle those also, touches also, everything it is available over here. So all these things are nothing but these libraries, guys. These libraries. Okay, some examples they have. So these libraries are SDK libraries used to implement your Android application as per your requirement. Okay. So what are all those? Can you tell me the list? Nobody can tell because we also cannot remember all these things. Just you can suggest selected SDK libraries. Example, button is a library. Button class is defined from a library. Checkbox is also defined from library like that. Widget components like that you have to tell. Okay. Right. Next, we have another library, Android Runtime library. So Android Runtime library. What is this Android Runtime library? Sorry, I told it is library, not library. It's Android Runtime layer. Okay. Execution. If at all I want to execute Android application. Okay. So if it is executing Android application, output generation. Output generation. What is Android output? APK. APK file. Okay. So these two things it is done. Okay. Android runtime layer, it contains two things. What are the two things? Core libraries, nothing but your Java libraries, Dalvik virtual machine. We have listened Java virtual machine. What is this Dalvik virtual machine? What is the use of that? Okay. So for that I have a image I have drawn. Just a moment. I'll just get it from my drive. Just a moment. I'm launching the drive. See, particular this thing is about APK generation. Okay. So in the demonstration itself, I told Android application is divided into two parts. Now I am explaining about DVM, Dalvik Virtual Machine. So how Dalvik Virtual Machine will generate the Android output. Okay, this is the thing. Android app, whatever your Android app is there, that Android app divided into two parts. One is backend. Okay. Next one is front end. In the backend, if you consider Java files only available, right? So every time we used to write .java. For example, here everywhere Sdk libraries are there. In my application, here Java, you will have main activity.java. Okay. So in the services, I will write ring service.java like this. .java files are available. So .java files, it is available in the backend. But how about front end? So in the front end, so many different folders are available. What is the front end folder is, see, there is Java folder, here is resource folder. In the resource, different folders are there. Drawable, used to kept images, layout, used to kept XML, this main.xml. Main.xml is, see, here I kept two buttons. Okay. So this is the complete screen. This is the complete screen. So these two buttons related XML logic is available. Okay. So this XML is available here in the layout folder. So these are also for images, and raw folder I have created. So in the raw folder I have used iphone.mp3. Okay. And if in my requirement I can also add some PPT, PDF like that. Okay. Anything I can add. So that is possible as per your requirement. So if I am adding number of things, okay, so in the front end, how I am going to be execute that XML files, images, languages, music files, PPT, PDF, whatever you want, you can add like that in your requirement. So all these things, front end, in our Android internally there is a tool available. So the tool name is Android Application Packaging Tool, AAPT tool. That AAPT tool, it is going to be convert all your front-end things will be into a simple .java file. So your all resources will be there. It will be manipulated and created a r.java class. For example, in my application, I placed a music file. So the music file, it will be converted into a integer variable. For example, so here I have taken raw folder. In the raw folder, I have given iphone.mp3. But if you see here, in one class, whenever I am accessing that, okay, see what it is giving: public, static, final, integer variable, iPhone, there is some value. I'll try to open. Like this. See, a ringtone service, that is sorry. Okay, you will get created a class R like this: public, final, class, your package name r.java. That is the reason here I have written like r.java. Inside the r.java, if at all I have a this is consider how I will treat you. Resource means r.java. Okay, in the layout I have XML, activity underscore main. So in the main activity I have called like this: set content view r.layout.activity underscore main. So what is this activity underscore main? See, public, static, float, final, int. Even your .xml file, the .xml file, it is converted like a integer variable. Okay, please note that. So everything it is going to be converted into integer. So who will convert that? AAPT tool will convert. So whenever I want to call in this one, I will call resource r dot layout dot activity underscore main like this. I have a button. So that button I have registered here as ID bt underscore play. In the activity bt play, what you have written, I have called like find view by ID r dot id dot button play. Even button play is also a int. So internally you are doing something. Button ID you have given something, but it is converted into integer. Who will take care about it? AAPT tool will convert and will be given to r.java. Okay, so already your backend is Java. Now your front end is converted into r.java. Now both become Java file. Okay, but this backend Java files we are using JVM, right? Initially we are using JVM. So before Android setup, you need to do Java setup because all the files you are going to be write as Java. So JVM must be there. What is JVM? JVM is Java Virtual Machine used to execute Java program. JVM contains two things. One is JDK, Java Development Kit. Second one, JRE, Java Runtime Environment. So JDK, what it will do, whatever the .java file it is there, that will be compiled and run, and output will be given as .class file, right? JRE, JDK. Then the .class file will be taken by JRE. So JRE will generate the machine code, machine understandable code. Okay. So that machine understandable code, again, DX tool, there is a DX tool available. The DX tool will convert into a particular format and it will send to DVM. After JVM, DVM will be involved. Dalvik virtual machine. So this Dalvik virtual machine at this point, your front end, whatever r.java file is there, that front end also it will bring and back end also it will bring. Together it will generate an output as .dex file. Okay, that's what I have mentioned in the DVM. .dex file will be generated. In the .dex file, what you have? Front end file as well as back end files. Combination. Okay, it is available. Okay, then whatever this dex file generated, .dex file, that will be given to another tool that is called Apk Builder tool. Apk Builder tool. That Apk Builder tool is responsible to generate a APK file with the help of dex file. So dex file is a compressed format of your code and everything. That compressed format need to be converted into an APK with the help of APK Builder tool. This is completely hidden. Okay, Android Studio will take care by initiating APK Builder tool when you click on run icon. Basically, every project have the run icon, run app. When you click on this, first it will convert all your things like front end will be converted into r.java, back end will be compiled and executed by JVM, and then it will send it to DVM. So both front end and back end will be merged together. It will generate a dex file. The dex file will be given to APK Builder tool. APK Builder tool will generate APK file. If your application is more than, for example, one second, I'll show you one proof. Before that, build outputs APK. Right click, show in folder, show. Analyze. File path. See guys, here how much KB it is? Show more options, properties, just it will be converted and given. So how much size it is? Just 4 MB. Okay, right. How about the project size? See, unbounded service. Unbounded service. What is the project size? Project size is 27.7 MB. It contains total 589 files, 343 folders. It's completely 27.7 or 26.7 MB. But your output is coming how much? Just 4 MB. It is a compressed format. Okay, that will be taken care by DVM. Compressed is dex. After that, again it will compress something and it will make your output. Okay, so I think you understand runtime. In runtime, two things only available. One is Java, second one is DVM. So these two responsibilities to make your Android application execution. That is okay. Next, we have fourth layer. Fourth layer. So what is this fourth layer is? Android application framework layer. Application framework. So what is this application framework? See, in the application framework layer, what you contain? Activity manager, window manager, content provider, view system, notification manager. Notifications, you know, right? Push notifications. Location manager. Location means what? Current location you will be able to calculate by writing latitude longitude, by getting latitude longitude. That latitude longitude who will provide for us? Location manager, resource manager, telephone manager, package manager. These are all called inbuilt services. Okay. Android inbuilt services. Inbuilt services. So what are these inbuilt services? What it will do? Okay. So these inbuilt services are helpful to make a task execution. For example, there is a location manager. Continuously, for example, nowadays you are using Ola, Uber cabs, right? So when you open the application, directly it will launch map and it will ask you to enter destination, because it is already capturing the current location of yours, because location manager is an object, it's a service. So when you launch Ola app, the service will run. And it is displaying for you the current location, current latitude, longitude. Okay, so and you need to search for the destination and enter. Once it is done, your location manager will estimate a route path. That route path calculation, how much time he can reach with the traffic or without traffic, also you will get updates. Okay, so all these things, inbuilt services, will be maintained by application framework layer. So during demonstration, I told we have third component services. Total 5 Android components are there. Activity, intent to service, broadcast receiver, content provider. So we are going to be use service here. All the services we have a separate topic for this. At that time we are going to be discussed. All these are all inbuilt services. So if I want to customize services, Android is facilitating. We can also discuss at that time. Okay. So here application framework layer, you can suggest, you can tell only one point. Android inbuilt services like location manager, network provider, telephony manager, so many things will be there. So those are all inbuilt services which are helpful to make your application work easy. That's it. Services layer. Other than that, nothing is there. Next, last layer we have applications layer. Okay. So this is the highlight actually. So whenever I have installed any application, okay, so that application, every Android application contains some icon, okay, some icon, some app name. For example, if you open your mobile phone, okay, in the home screen, Facebook app will be there, Instagram app will be there, and this what we can say, WhatsApp, Facebook, and any different thing like you are using different apps, games or something. Every app has a unique icon, right? And unique icon as well as unique name. Okay, so all these things, it is going to be all the apps, whatever you are, it is displayed, all it is going to be displayed in the applications layer. Okay, it is going to be maintained over there, applications layer. So applications layer also have some default system related applications. For example, home, contacts, right? When you purchase phone and on very first time, contacts option is available. Okay, phone, that means call history, that one. Browser, some default browser for Samsung browser is available. After that, you are going to be installing Chrome, Mozilla, Firefox, like that. Okay, so many things will be there. Okay, all these things, uh, uh, whenever you install any app, that will be reside inside the applications layer. So for example, I'm clicking on contacts application. Basically, contacts application means what? You are going to be store your friend contact. Okay, what are all the mandatory required contacts you have? Okay, those contacts you are going to be saved. What will happen when you open contacts is, see, observe whatever I am telling now. When I just click on contacts, this contacts applications layer contacts, it will come to application framework layer and it will contact with content provider. Content provider is nothing but database. Contacts application will request Android content provider service to check any contacts database available in my Android phone. In my Android phone, is there any contacts database available? That contacts database, if it is existed, okay, so then it need to check with database content provider. Content provider will give an order or command to libraries layer SQLite. So SQLite can check inside any contacts related libraries available or any files available. If it is available, it will send a acknowledgement to content provider, then contacts will display the database. So here what is happening? Applications layer component is communicating with application framework layer component. Application framework layer component is communicating with libraries layer. That means here is our requirement, here is our solution. So all these layers are having inter-process communication. It will depend on each other. Okay, so application layer requirement is it need to be communicate with all other layers to capture your data and display on the device. That is the main intention. Okay, so I think you understand what is that applications layer. Applications layer making communication with other layers for user requirement. Based on your requirement only, it will make communication. That is the reason we are having that applications layer, and all the apps what you have installed, that will be available in the applications layer. Okay, that's it. Other than this, nothing is there. So now you are able to understand whenever I am writing. Okay, so okay, XML I am writing here, but XML will be in different part. While executing, DVM will come like that. So APK is getting generated by this one. Okay, so whenever I say service, application framework layer, like that. So just these things you need to remember. Okay, just layers name, what is its main functionality. Other than that, nobody will ask how many drivers are there. Can you explain me what are the 160 drivers? Because even I also don't know what are the 160 drivers names. Okay, we know the count as per vendor. When I went vendor visit, so the count of stack they have displayed. So there I have seen, even though it is a confidential information. So one of I made one client friend, then I have seen this in one of the mobile vendor. Okay, so like this we have some different things. Okay, so that's it about architecture. Okay, so based on this architecture only, our complete Android operating system design, and we are working every day. Okay, so tomorrow when we start, you have already installed uh, Android Studio, I guess, right? If anyone facing problem, please let me know. I will make it. So I'll resolve the problem and make it work. Tomorrow morning we are going to be start Android front end design. Okay, let's start practicals from tomorrow. So I think you are ready with the Android Studio. Okay, so we'll start writing, learning. First 15 to 20 minutes I will explain theory. Sorry, somebody. Anil, you have installed
Nothing.
Yes, sir. I have already installed the Studio One. Okay, and
okay.
I have also tested. It's working fine for me.
Yeah, okay. How about phone?
For me also it's working fine.
Okay,
Bit
then.
clumsy.
Oh, sure. Okay, then it's all good. So now what we need to do, we'll start working from tomorrow, uh, how to write front end, and some properties are there. 15 minutes I need to explain. So what are the main things? After that, we'll start integrating front end designing. Once it is done, basic programming we will see. Once it is done, we'll start components.
Sure,
Okay,
sir.
like that we'll go one by one. So that's it from my side today. Any questions here?
No, sir. No, as of now.
Okay. Okay, yes. Thank you so much. See you 6 a.m. tomorrow with front end design. Okay.
Sure, sir.
Right.
Thank you.
Thank you.
Thank you.
Thank you so much.
Thank you.
Yeah. Yeah. Bye.